The purpose of this experiment is to represent how oscillations work using a simple pendulum. An oscillation is also known as a periodic motion, and it is the repeated back and forth movement of something between two positions. An oscillating movement occurs around an equilibrium point, which is the starting point. The setup of a simple pendulum consists of a stand with a rod at the top, which has a string tied to the rod, so that a ball mass can hang at an equilibrium point at the bottom. This equilibrium point is a state of no motion with the hanging mass, but when the ball is raised to one side and let go, it has a continuous motion by swinging back and forth because gravity acts as a restoring force. Then a certain number of oscillations will be counted and timed in order to calculate the period. This will be tested various times by changing the length of the string. Then the acceleration due to gravity can be calculated after finding the periods in order to compare experimental and theoretical values. There were 6 different trials run for this experiment using 6 different string lengths in order to compare the average periods of oscillation, as well as compare the average experimental acceleration values to the theoretical value. The period of oscillation values come from averaging together the time it took to complete 10, 20, and 30 oscillations. Now that the period had been found, the acceleration due to gravity could also be calculated for each trial, using the equation previously shown as acceleration equals 4 pi squared times the length of the string over the period squared. The average acceleration due to gravity came out to be 10.34 meters per second squared, which yielded an average percent error of 5.4%. when compared to the theoretical value of 9.81 meters per second squared. This shows that the experiment was successful overall by being close to the theoretical value. The frequency of oscillation compared to the length of the string shows a linear correlation. This is expected because a pendulum with a longer string has a lower frequency, meaning it swings back and forth less times in a given amount of time than a pendulum with a shorter string length would. So period and frequency of oscillation are reciprocals, which means that 1 over period is the same thing as frequency. So when both sides of the period equation are squared, the relationship between frequency and length can be determined. We found that the frequency squared is inversely proportional to the length of the string, as shown on the graph. All the data was calculated in the same way as this example shown using the 19 centimeter length string. First, the period of oscillation came from averaging together the time it took to complete 10, 20, and 30 oscillations. So then that average period value was plugged into the acceleration equation. The acceleration found was then compared to the theoretical value of acceleration by gravity, which is 9.81 meters per second squared. It came out to a 13.66% error. This process was repeated with each of the other different length strings tested.